Hi guys, how are you? Uh, Hopefully you all will be good. Today we will discuss the topic about the data link layer. Okay, in this chapter we will cover the major functionalities of data link layer. In today lecture, uh, we will cover the Ethernet framings. Okay, what is Ethernet framing? Okay, as you have studied the OSI layer, TCP/IP layer, and novel layer. Uh, Today we will cover these all layer in this lecture. As you all know, uh, to communicate two devices, we need a transmission media, a transmitter and a receiver. Okay, to communicate these entities, we follow certain rules which are defined by IEEE. IEEE also defined the pattern of framing. So today we will discuss the different format of framing. Okay, what is the objective of this chapter? Uh, in this chapter, we will cover the reference model of networks, in like a TCP/IP model or a SI layer. Okay, and novel IBM model, etc. Uh, Second, we will discuss the frames construction. Okay, how the frame are constructed. Okay, before sending. Okay, and third, we will discuss the MAC addressing. Okay, we all better know there are two types of addressing. One is physical addressing and one is logical addressing. You all have listened the same thing. Like my computer is connected with a network. Okay, suppose my network is in the form of uh, 192. Okay, 168.1.1. This type of addressing are called IP addressing, and IP addressing are also called logical addressing. Okay, we will discuss in our future classes different types of IP addressing. Okay, like IP addressing 32 bits and IP version 4, which is 32 bits, and IP version 6, which is 128 bits long. Okay. In third, we will discuss the uh, Ethernet framing and how these frames will be forwarded. Okay. Now we will discuss the different models. These models are like a TCP/IP model. We have four models, four different types of model. Okay. Novel model, I have OSI layer. Okay, OSI. Its name is OSI layer, and the organization which have developed are called ISO, International Standardization Organization. And what is OSI? Open System Interconnection. A novel model. Okay, and IBM model. Okay, these all are a model, a reference model. Okay, suppose if you want to study anything, okay, for that you will point out a reference. Okay, that reference model will help you to understand the whole functionalities of any network. Okay, What is TCP IP model? Okay, TCP IP model is a reference model, and it is also called a protocol suite. Okay, why it is called a protocol suite? Because TCP, transmission control protocol, is a protocol, and IP, internet protocol, are a protocol. That's why it is also called reference model and protocol suite. Okay, first we will study the TCP IP model. Okay, what is the TCP IP model? It is the first model which was first used in uh, first network like ARPANET. Okay, in 1950s. Okay, this model is consist of four layers. Okay, one layer is called application layer. First layer is called application layer. Okay, second layer is called transport layer, third layer is called network layer, and the fourth layer is called network interface layer. Okay, these all layers have different functionalities. Okay, application layer provide a interface to any user. Okay, suppose if you want to access a network, okay, the application layer provide you an interface to watch a videos, to send your emails, uh, to read your text. Okay, this is the functionality of application layer. Okay, what is the function of transport layer? As uh, uh, its name is transport, this layer performs the functionalities of transportation. Okay, this layer guaranteed the error free transmission of a data, mean this layer transfer the data from source to destination. Okay, maybe it transfer your data uh, through shortest path. Okay, or it also help us to maintain the speed of data. Okay, the protocol used in TCP, sorry, the used at TCP transport layer is TCP. Okay, transmission control protocol. Okay, this protocol is used to control the whole functionality of transportation. Okay, another protocol which we discussed in our advanced course like HCIP. Okay, there are two types of protocol. You should differentiate it. Okay, one is TCP and other is UDP. Okay, one is TCP and one is UDP. TCP is a reliable communication. Mean it transfer the data by following approach is three hand checking process. Okay, in case it's uh, perform the authentication. Okay, while in UDP there is no authentication, mean it is not a reliable protocol. Okay, where we use TCP and where we use UDP, in certain cases. Okay, where the data is very sensitive. Okay, in that case we use TCP. Okay, I mean it will authenticate. Okay, and it will investigate, it will observe the transmission of data from transmitter to receiver. Where we use UDP, UDP are used in some cases where speed is necessary. Okay, where authentication is not necessary. Suppose like a video conferencing. Okay, broadcasting, video broadcasting. Okay, in that case, we used a higher speed. Okay, uh, that's why we use a protocol like UDP. UDP is unreliable protocol. Okay, while TCP is reliable protocol. Okay, the next one, The next layer is a network layer. Okay. uh, what is the functionality of network layer? It maintain the network, it's maintain the networking routes. Okay. It's maintain the IP addressing, like logical addressing. Okay. Network layer control the logical addressing. Okay. And also perform the routing. Okay. Suppose if your network, your PC is connected with a network, this layer perform the routing. Okay. The protocol used in this layer are called IP protocol. Okay. Internet protocol, IP internet p protocol. Okay. The next layer is network interface layer. Okay. This layer, as the application layer, provide the interface to the user. Okay. This layer provide the interface to the network. Okay. In this layer, the process of framing take place. Okay. I mean, the network interface layer provide the interface to the network. Okay. While application layer provide the interface to the user. Okay. Okay. Next. uh, the next model is OSI model. Okay. OSI, open system interconnection. Okay. OSI model was developed by ISO, International Standardization Organization. Okay. This model was developed by ISO. Okay. As the TCP/IP model is 4-layer model, while OSI layer model is 7-layer model. Okay. Uh, In OSI layer, uh, the layers are in the form of application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Okay. What is the functionality? As we have already discussed, the application layer provide the interface to the any applicant or any user. Suppose if you want to watch a videos or movies or to read a data or article, through application that provide or give you a specific interface to read or listen that data. Okay. The next layer is presentation layer. Okay. What is the functionality of presentation layer? Presentation layer uh, represent your data in a specific format. Okay. Which will be accepted by a specific network. Okay. The presentation layer present or arrange your data. Okay. In a specific pattern which would be suitable for any network. Okay. Another function of presentation layer is encryption and decryption. I mean, encryption and decryption are used for your security purposes. Okay. I mean, for your safety, you should encrypt your data, network encrypt your data, while at the receiver end, encryption take place at transmitter end, while decryption take place at the receiver end. Okay. The next layer is a session layer. What is the functionality of session layer? As its name, session layer. Okay. This layer maintain a session. Okay, a specific session. If the session is about 1 hour, the session layer maintain this 1 hour complete session. Okay. This is the functionality of a session layer. The next layer is transport layer. As we have discussed already, this layer perform the process of transportation, meaning error-free delivery of data. The protocol used at this layer are TCP, IP transmission control protocol, and IP protocol. Okay. The next layer the next layer is a network layer. As we have already discussed, the network layer perform the process of addressing, okay, and routing. Addressing in the form of logical addressing, like IP addressing. Okay. Like 192.168.1.1. Okay. While also perform the process of routing. When you want to transmit your data, it routes your data on a specific path. Okay. The next layer is data link layer. Okay. the the functionality of data link layer, one function of data link layer that it provides physical addressing like a MAC addressing. Second function of data link layer are framing. Okay, the third function of data link layer are medium access. Okay, that which type of medium you are using. Okay, it provide the access to that specific medium. Okay, the last layer is called physical layer. Okay, physical layer is the last layer. Okay, and it is also called the first layer. Okay, the last layer or the first layer. Okay, okay, what is the functionality of physical layer? It provide a physical interface while it is direct connected with any medium, which may be coaxial, which may be fiber, which may be twisted pair cable. Okay, this layer perform the process of bits. Okay, suppose if you want to transmit your data remain message. Okay, okay, your data. Okay, we'll study this in our next slides. First, I will discuss one main point. Okay, uh, these four layer like application layer, presentation layer, session layer. Okay, these three layers are user support layer. These three layers are called user supported layer, while these three layers are called network supported layer. Okay, these are called user supported layer, while these are called network supported layer. Okay, what is transport layer? Transport layer is the interface between user supported layer while network supported layer. Okay, understand? Okay, okay. As when you transmit your data will remain data at application layer. Okay, it is further transferred it into presentation layer. Okay, in presentation layer it remain data. In session layer it remain a data. Okay, at transport layer. Okay, certain headers are added with this layer. Certain header are added with your data. These are header. Okay, transport layer, some header are added with data to transmit. Then this data is transmitted to network layer. Okay, at network layer some further header are added which are in the form of IP addressing. Okay, mean they address the source IP addressing, the source IP addressing and the destination IP addressing. Source is a transmitter while destination is a receiver. Okay, a data link layer, the header, okay, and the tailor both are added. Header in the form of MAC address, source MAC address and destination MAC address. Source MAC address and destination MAC address at the header and type of data. Okay, which type of data you are using. Okay, at this layer the header and tailor are added. What is tailor? Tailor are checksum. Okay, checksum is a process which will check the process of that your data is correct or not. Okay, at your destination layer. Okay, last layer is a physical layer in which the data can be transmitted in the form of electrical signal or in the form of bit. Okay, at this layer At this layer, a physical layer, the data is in the form of bits. Okay. A data link layer, the data is in the form of frame. Okay. At network layer, the data are converted in the form of packet. Okay. At transport layer, the data are converted in the form of segment. Okay. Okay, data is converted in the form of segment. At physical layer, data is in the form of bit. At the data link layer, data is in the form of frame. At network layer, data is in the form of packet, while at transport layer, data is in the form of data is in the form of a transported data is in the form of a segment. Okay. Okay. Further, the next model is novel model. Okay. Novel model is also a well-known local area model in which was developed by Novel. Novel is a company. Okay. They develop a model which are called novel model. In novel model, IPX are two protocol which are using in SPX. I mean Internet Packet Exchange. Okay. And while SPX is called Sequence Packet Exchange. IPX is in the is similar like IP, while SPX is similar like TCP. Okay. This is also model like similar like a TCP/IP or a SILA model is also an reference model. The last model is IBM. Okay, IBM also introduced a model or a reference model. Okay, this model is also a local area network model. Okay, and the IBM, the protocol used in IBM are called SNA. The protocol used in IBM are called SNA. Okay. These are all three or four types of model like OSI model, and TCP/IP model, novel model, and IBM model. Okay. 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 What is framing? Okay. And what is the functionality of any devices, how the data can be transmitted between two devices? Okay, either the data can be transmitted in the form of bits or data can be arranged in a certain format which are called frames. Okay, as I said in before that when you want to transmit your data at the data link layer, the header is added to your data and a tailor also added to your data. What is the header and what is the tailor, we will study in next slide. Okay. Listen, uh, we have uh, As I said that the data link, the header and header are added to your frame. Okay, what is a frame? Okay, and how many types are there for a framing? There are two types of framing. Okay, one is Ethernet 2, and other one is IEEE 802.3. Ethernet 2 was introduced in 1980, while it was replaced by IEEE 802 in 1983. Okay, in Ethernet 2, at the header, suppose it is header. Okay, I will draw. I will draw as it is header and it is tailor. Okay, header is further composed of in Ethernet 2. Header is composed of destination MAC address, okay, source MAC address in a type of a data that is preceded by your original data, and data is data after your data, there is a frame checksum. Okay, checksum is a process, and to the destination you can check your data, okay, by adding some bits that your if the result come that a specific result, then they will show that the desired data is error free data. Okay, in Ethernet 2, the header is composed of destination MAC address, source MAC address, and a type of a data, while in IEEE 802.3, the header is composed of destination MAC address, similarly source MAC address. Okay, suppose what is destination and what is your source. Okay, suppose this is called your source MAC address. Okay, and it is called your destination MAC address. What is MAC address? Media access control. Okay, as you all know, NIC, I think you all know the point where you connect your Ethernet point. Okay, Ethernet cable, that point is called your NIC. What is NIC? NIC, network interface card. Okay, it is a physical addressing. Okay, this specific form of this is specific or a unique addressing is assigned by manufacturer and IEEE. It is 48-bit IP addressing. Okay, 24 are assigned by IEEE, while 24 are assigned by organization. MAC address is 24 48 bits address. Okay, similarly IEEE 802.3 header is composed of destination MAC address, source MAC address, length of your data. Okay, and logical, the this the type is further in IEEE 802.3 Ethernet framing. The types are further divided into length. LLC mean logical link control. Okay, what is LLC we will study, and what is SNAP. Okay, the type of data in both framing. What is the type? Type will show that either the protocol is SPX or IPX. Okay, it will identify which reference model are used or which protocol are used, okay. Either it is TCP, IP are used, or SNA, like IBM. The functionality of type identify which type of data is used. While in IEEE 802, the type is further divided into length, okay. It will identify the packet length, sorry, the frame length, okay. The length identify the length of any frame. And logical link control, LLC, it is the interface between the logical addressing like IP addressing and MAC addressing, okay. Between these two addressing, LLC, okay. It is the interface between IP addressing and MAC addressing, okay. Understand? Okay. The next one is SNAP. Okay. What is the functionality of SNAP? SNAP perform the process of multiplexing. Do you know multiplexing? Multiplexing is a process. Suppose if we have Android computer, okay, and we want and all 100 computer want to send a data, okay. In that process, we combine the whole data and form a single stream of bits, okay. This process is called multiplexing, where we combine multiple signal and form a single signal. Uh, that process is called multiplexing. Multiple signals join together to form a single signal. It is called multiplexing. That similarly, data is originally your data, and FCS is checks and process. Okay. As I said that uh, what will be the length of any frame? Okay, how the computer identify either it is Ethernet 2 frame or IEEE 02 frame. If the field value mean your data length is greater than or equal to 1536, okay. If your data rate, okay, is greater than 1536, then the frame type is Ethernet 2 framing. If the data length is less than or equal to 1500, okay, then it will be called well, it the network identify that the framing type is IEEE 802 dot 3 framing. Okay, okay, next. And it will also identify uh, the protocol like uh, the protocol like A or P, and other is R A or P, okay. Address resolution protocol and reverse address resolution protocol, okay. If you have a MAC address, okay, you have physical address, okay, then you will find a IP address. That protocol are called ARP. Suppose if you they have given the MAC address, okay, then you will find the IP address of a specific entity. Suppose if I give the MAC address of this computer, okay, the destination computer, okay. At this point, I will give only the MAC address, but not give you the IP address. Through ARP, you will find the the IP address of host B. Okay, if I give the IP address, suppose if I have given the IP address of host B and not given the MAC address, okay, through RARP, reverse address resolution protocol, you will find the MAC address. This is also the functionality of type. Okay, okay, hopefully you will get my point. Okay, we will move further. Okay, the next is Ethernet framing. As I have already discussed that destination, the Ethernet framing consists of destination MAC address, source MAC address, okay, types, okay. If the data are come in the form of this type, okay, 0 multiplied by 0800, then it will identify that the packet is or data is in the form of IP format, okay. If it, as I already discussed, if the data come in this type, okay, then it will identify that the data is a ARP, address resolution protocol, okay. Mean you have only MAC address, now you will need to find the the IP address of that device, okay. Okay, as I said that the MAC address or Ethernet frame are uh, no, sorry, what is the length of any frame, okay. In Ethernet 2 framing, okay, in Ethernet 2 framing, the length of data is from 46 bit 46 bytes to 1500 bytes. Mean in any frame you can arrange 46 to 1500 bytes, okay. Then 4 bytes your checksum, okay. 2 bytes is type, 6 byte is source MAC address, and 8 bytes are destination MAC address, okay. The original data is up to 1500 bytes, less is 46, while greater is 40 1500 bytes, okay. What is the length of data in Ethernet IEEE 802.3? Okay. As we have already discussed, IEEE 802.3 frame consists of destination MAC address, source MAC address, length, okay, logical link control in SNAP. Okay, we have already studied the data is in IEEE 802. The data is from 38 to 1492 bytes. In that case, uh, the data is less data is 46, while greater is 1518. While in Ethernet framing 802.3, the higher lower data is 38 bytes, while highest data is 1492. Okay, that while in IEEE 80, Ethernet 2, and the highest data is 1518. Okay, 1518. Okay, hopefully you have got my point. Okay, frame forwarding. How the frame? Suppose you have constructed your frame, or no, you want to transmit this frame. Okay, okay. You will you will forward your frame by identifying the MAC address. Which MAC address? Destination MAC address, okay. If you want to transmit the frame to host B, you will add the destination MAC address in the frame, okay. After that, when you transfer your data from host A to host B, okay, your this data will be compared to the all MAC address. Suppose if there are suppose if there are C, D, okay, E, we have five systems, okay. Then your this data will be compared with C, with D, okay, with E, and also with B. Okay, if the MAC address match with host B, then host B will accept your data. Okay, understand? Next is the MAC address. As I have already uh, discussed that what is MAC address. MAC address is a media access control. MAC is the abbreviation of media access control. It is a physical addressing. Okay, it is 48 bits uh, address or 6 byte address. 6 byte or 46 bits, sorry, 48 bits. Okay, it is for 6 bytes or 48 bits physical address. Okay, 24 bits are assigned by IEEE, while other 24 are assigned by any organization which are going to manufacture a specific device. Suppose your computer, we have HP computer. Okay, suppose the HP company request the IEEE that I am going to design my computer. Okay, model like Core i3. Okay, then kindly issue me MAC address. Then IEEE assign it 24-bit MAC address. Okay. Then the further 24 bits are provided by the organization like HP. Mean 24 bits are provided by HP and 24 bits are provided by IEEE. Okay. This is MAC addressing. Okay. Hopefully, what is unicast? There are three types of frame forwarding. What is unicast? Okay, in unicast mean only one station can receive your data. Unicast mean uni mean one. Okay, mean only one center can receive your data. How the network will identify? Suppose we have a network here. Suppose one computer, two computer, three computer, and four computer. Suppose us here want to transmit a data, okay, to only one device, which is B, okay, and there is also a host C and host T. In unicast, how the system will identify that only B will receive the data, okay, if the seventh bits, okay, as I said that the MAC address is composed of 48 bits. Okay, if the first byte, okay, means 6 byte, okay, 1 byte, 2 byte, 3 byte, 4 byte, 1 2 3 4 5 6, okay, 6 8 the 48. Okay, the first byte, it is a first byte. Okay, it is second, it is third, it is four, it is fifth, it is sixth. Okay, we will study only first byte. If the eighth bit, in each byte there are 8 bits. Okay, suppose there are 8 bit, 8. Okay, similarly in these all bytes have their own bits. if the last bit, suppose it is 1 1 0 1 0 1 2 3 4 5 6 7 8. Okay, this is the last bit. Okay, if the last bit is 0, then the MAC address will identify that the framing is in the form of unicast. Okay, unicast mean 1. Okay. Okay, what is broadcast? What is broadcast? In broadcast, there is it is similar like your TV transmission, like your radio transmission, in which there are one transmitter and multi receiver. In unicast, there is only one transmitter and one receiver. In broadcast, there is one transmitter and multi receivers. Okay. Suppose if host A is a transmitter, the B, C, and D all are the receiver. These all devices receive the same data. Okay, how the network will identify that the frame is a broadcast? Okay, it is not human being. How it will identify that the network is a broadcast? If all bits are 1 1 1 1 1 1 1 2 3 4 5 6 7 8. Okay, these are 1 1, these are 1 1, these are 1 1, these are 1 1, these are 1, these are 1 1. Okay, if all bytes are 1 1, then the network identify that the framing is uh, broadcast. And the next one is multicast. In multicast, broadcast is one to many. Okay, but not specified, but not grouped together. Okay, multicast is also one to many but specific. Okay, suppose if there are 100 user in a specific area, in the case of broadcast 100, all 100 will receive the data, while in multicast only the specific user or the specific entities will receive the data. Suppose if there are 100 user in a specific ground. Okay, and you will identify that the host 1, the host 3, the host 9, the host 11, the host 17, the host 21, the host 22, the host 24, 25, 26. Okay, that you mean in out of 100, you identify that only 20 will receive the data. One to many but specific are called multicast. Okay, hopefully. Okay, in multicast, if the first byte, eighth bit are 1, then it will identify that the broadcasting and the mode of forwarding are multicast. Okay, next is carrier sense, and as we in previous class we have already that there are two type of carrier sensing. One is called CSMA, one is called, we have already discussed. If you have any problem in this topic, you can ask. CSMA CET, carrier sense multi carrier sense, sorry, CSM CS, I will log in. C CS carrier sense multiple access code detection. Okay, if there is a physical medium, okay, in that case, suppose a host A want to transmit a data to host C. Okay, at the similar condition, host B want to send a data to host A. Okay, in that case, data come from here and data come from here. Okay, at that position the data collide. Okay, how to control this type of collision? The process use carrier sense multiple access code detection. Mean, first
A will send a carrier. Okay, it will sense that medium, either the medium is free or busy. If the medium is free, then it will send a message that the medium is free. Now you can send the data. Okay, means sense. It will check or investigate the medium. Okay, the next one is CSMA, 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 carrier sense multiple access code avoidance. If the medium is air, okay, in air you cannot identify which station is going to send the data. In that case, you will try to avoid a collision. Okay, that is another type of. This is another type of carrier sense multiple access technique. Okay. Frame processing. Okay, how when host A send its frame to host B, okay, at the destination end, okay, they will remove this all data from it. Okay, I mean it will remove the MAC address of B, okay, the MAC address of source, MAC address of destination, okay, and also IP addressing, okay, and FCS bits, okay, and FCS is used to check the error, and you will receive only the data. This is all. These are questions. You will answer these questions by yourself, okay. This is our next lecture. Hopefully you will understand. If you have any queries, any question, please write your question below in comments line. I will answer these all questions. Enough for today. Inshallah, we will meet in our next class.